Okay, so it reads, it says, until recently, most astronomers, come back. I need to get rid of this. Until recently, most astronomers believed that the space between galaxies in our universe was a near perfect vacuum. This orthodox view of the universe is now being challenged by astronomers who believe that a heavy rain of gas is falling into many galaxies from the supposed empty space around them. The gas apparently condenses into a collection of small stars, each a little larger than the planet Jupiter. These stars vastly outnumber the other stars in a given galaxy. The amount of intergalactic rainfall into some of these galaxies has been enough to double their mass in the time since they formed. Scientists have begun to suspect that this intergalactic gas is probably a mixture of gases left over from the Big Bang when the galaxies were formed and gas was forced out of galaxies by supernova explosions. It is well known that when gas is cooled at a constant pressure, its volume decreases. Thus, the physicist Fabian reasoned that as intergalactic gas cools, the cooler gas shrinks toward the center of the galaxy. Meanwhile, its place is taken by hotter intergalactic gas from further out on the edge of the galaxy, which cools as it is compressed and flows into the galaxy. The net result is a continuous flow of gas, starting as hot gases in intergalactic space and ending as a drizzle of cool gas called cooling flow, falling into the central galaxy. A fairly heretical idea in the 1970s, the cooling flow theory gained support when Fabian observed a cluster of gases in the constellation Perseus and found the central galaxy NGC 1275 to be a strange-looking object with regular thin strands of gas radiating from it. According to previous speculation, these strands were gases that had been blown out by an explosion in the galaxy. Fabian, however, disagreed. Because the strands of gas radiating from NGC 1275 were visible in optical photographs, Fabian suggested that such strands consisted not of gas blown out of the galaxy, but of cooling flows of gas streaming inward. He noted that the wavelengths of the radiation emitted by a gas would change as the gas cooled, so that as the gas flowed into the galaxy and became cooler, it would emit not X-rays but visible light, like that which was captured in the photographs. Fabian's hypothesis was supported by Canizzare's determination in 1982 that most of the gas in the Perseus cluster was at a temperature of 80 million degrees Kelvin, whereas the gas immediately surrounding NGC 1275, the subject of the photographs, was at 1/10 of this temperature. Okay, so what did we just read?
I understood that there's a scientist trying to figure out where the gases in the galaxy come from.
Okay.
And so then there's like two theories, but I didn't understand half of what it says.
Okay, so who were the two people that were theorizing? There's two names.
Fabian.
Fabian is one of them, right?
And then the other one.
So we need Mr. Fabian here. That's one. The other one is toward the end. Can you find him?
No, I don't remember his name.
Well, he's on the screen. So here's Fabian again down here, yes. Right?
Well, he had it.
And it says, look down here. You see? Right here. Fabian's hypothesis was supported by Canizares' determination that most of the gas was at a temperature of 80 million degrees Kelvin, right? Now, you got that. Okay, what else? How many theories do we talk about in here?
There's two.
That's right, there are two. Very good. There's the orthodox view of the universe right here. Okay. There's also this thing. The heretic, do you know what this word heretical means?
No.
Okay. Do you know the word orthodox?
Like when I think of the word orthodox, I remember the dictionary.
Oh, like the Oxford English Dictionary. Okay. Actually, think more in religious terms. So orthodox and heretical are pretty much antonyms. Okay. You usually see this in religious circles. Orthodox doctrine or orthodox theory in this case is going to be the one that orthodox means that it fits the established belief.
Okay.
Okay, so if this is an orthodox religious practice, then it fits what the church believes. Okay, it fits the established belief. That's what orthodox means. So the orthodox view of the universe. Now, what does the orthodox view of the universe say? Well, if you read it up here, it says that the orthodox view of the universe was a near perfect vacuum. Okay. Now, in this case, we're not talking about a vacuum like a vacuum cleaner. Okay. We're not talking about something you clean your floor with. We're talking about a vacuum, meaning that it doesn't have any light in it whatsoever. It sucks in all the light. It's like a black hole. There's nothing there. Space is a vacuum. Okay. So that's what we used to think. That's the orthodox view. Okay. So the orthodox view here is that space is a vacuum, right? That's what,
that there was nothing.
I'm sorry.
Basically, they thought that there was nothing.
Yeah, essentially, right? But that's now being challenged. So it's not, they're challenging this orthodox belief, right? And the majority of this essay is about the other belief, which is what?
Fabian's theory.
Yeah, Fabian advanced it, but again, read, okay, yeah, and that there's nothing wrong with what you said. Okay, so this orthodox belief, this vacuum,
gas
now being challenged that because astronomers believe what? About this heavy rain of gas, right? Yeah. Well, if there's heavy rains of gas and the flows are what's making stuff flow into it, then guess what? It's not a vacuum anymore, right? Now, okay, so you kind of see where this is going? So now the whole heavy rain thing is all about where does the rain come from, right? Because if you think that space is a vacuum and now there's rain out there, Where's the rain coming from?
Okay.
Rain, it turns out, comes from the small stars, and then the gas. So you have gas here. They're talking about like vapor. Think of like, don't think of gas in your car. Think of air.
Okay.
Air is a gas. Anything that has like a smoke would be a gas state. Anything that is like a vapor. Okay. This is not oxygen, but just think of a gas in that sense. It is well known that when gas is cooled, okay, at a constant pressure. So think of, in this case, it's kind of weird. It might be kind of weird to think of gas having pressure, but it does, okay? Just like, I don't know if this will make a lot of sense to your experience, but have you ever been in a pool or in water?
Yes.
Okay, so you know that when you get in the pool, the water puts pressure on you, right?
Yes.
And the further down you go, the more pressure there is on you, right? Well, air is kind of the same way. We have air pressure. We call it barometric pressure, right?
Mhm.
So air pressure is higher at some places and lower in others, right? But the pressure that air or gas exerts depends on the pressure, right? Now, we can talk about the environmental pressure that you have, but we can also talk about creating pressure artificially. Think of like, think of like oxygen tanks or any kind of aerosol can that you've ever bought, like deodorant, spray paint, anything like that, right? If you ever read the back, it says, contents under pressure, do not puncture or incinerate, right? Don't puncture and don't throw it in fire. Why? Because those gases are under pressure, they're gonna explode. And the contents are gonna come out, not to mention the container is gonna blow to bits, okay? So if you take gas, vapor, and you cool it at a constant pressure, you cool it off, and the pressure stays, in this case, it stays the same, okay? We don't really care what that pressure is, but if you cool gas with a constant pressure, you cool it off, what happens? You decrease the volume, okay? So you cool the gas off, and what happens is the gas is still gas, but it takes up less space. That's what it's saying, okay? Now, because we know this is a well-known thing in physics, okay? What I just explained to you. So this guy Fabian said that as intergalactic gas cools, as this vapor in the galaxy cools, the cooler gas shrinks, because that's what gases that cool do, they get smaller, right? They shrink inward toward the center of the galaxy. Okay. But now there's empty space, right? Out there because it's flowing to the center, right? So what's on the outside where the gas used to be? Meanwhile, its place, the place of this now cooler gas, meanwhile, the place that the cooler gas used to occupy is taken by hotter intergalactic gas from further out on the edge. So on the edge, it's hotter, right? And as you go toward the center, it shrinks and gets cooler.
Okay.
Is what this is saying, okay? Which cools as it is compressed and flows into the galaxy. Okay. So now, before I read the next sentence, what would that mean? What's going on in the galaxy now? You have hot gas on the edge.
Mhm.
You have cool gas in the center. right? And what do they seem to be saying? Where is the rain coming from?
I have no idea.
Well, okay, so remember, we start with hot gas on the edge, right? So you've got my bad impression of a galaxy, right? And here's stuff in here, right? So what kind of gas is out here on the edge? Is this hot gas or cold gas?
That's hot guy. Gas.
Right, this is hot gas, right? And what's happening to the hot gas?
Is compressing.
Right, so it's going toward the center, right? And this is where the cool gas lives. Okay, cool gas lives here. Now, if you have cool gas in the center and you have hot gas flowing from the edge to the center, let's say I've got this, let's say there's a,
they're gonna touch and it's gonna create the explosion.
okay, but not quite, because these aren't separate. This hot gas became cooler. They became cooler. So this hot gas is the same particle. It's just colder now than it was.
Oh, okay.
It's just colder. But you're on the right track. Okay. But this hot gas is the same. When it's out here, it's hot, right? When it's in here, it's cool. Right? So now what happens to this hot gas that moved? Now there's space out here, and here comes more hot gas, right?
Mhm.
So this hot gas takes the place of, you know what I mean? So what you have is a cycle going on, right? It's not just all the hot gas becomes cool and it rains and we're done. Because then the rain would stop eventually, right? And it doesn't. So you've got more, you've got this constantly replenishing circle. Hot gas flows inside to cool gas, and then there's more hot gas that comes and takes the place of this. You see what I mean?
Mhm.
Now, okay, so you kind of see how that's going? You kind of see where that's at now?
Mhm.
So it says the cooler gas shrinks inward toward the center. Meanwhile, the place of this cool gas is taken by hotter intergalactic gas from further out on the edge, which cools it as compressed, and it flows into the galaxy. The net result is a what? It's a continuous flow of gas,
Gas. So it just continues the cycle.
starting as hot gases in intergalactic space.
Okay.
Now, what happens to this cool gas? That's where this cool gas falls down as rain into the galaxy down here. Okay?
Good.
Does that kind of make some sense? Does you kind of see where that's going? So now, this in the 70s, which 1970s, we're talking 50 years ago, this was heretical. Why? Because what did we used to think? That the universe was a vacuum.
Yes.
Right? So this used to be heretical, but this cooling flow theory gained support. Why? Because our Mr. Fabian made an observation. He made a lot of observations, but they tell us about a specific observation that he made, right? And he said he observed a cluster of galaxies in the constellation Perseus. We don't care where they are. A constellation is a group of stars, okay? And at least in the US, our constellations are named after a lot of Greek heroes from
Yes.
Greek mythology. Perseus is somebody from Greek mythology. So this constellation is named Perseus.
Okay.
And Fabian, not Perseus, because Perseus is not real. Fabian found the central galaxy, because remember, the gases flow into the galaxy, right? And this galaxy doesn't have a name, it has a number.
Okay.
Called NGC 1275. Okay. And he found the central galaxy, and this is what it looked like. It was a strange looking object with irregular thin strands of gas coming from it. Now, it doesn't say it had rain or moisture coming out of it. It said it had thin strands of gas. So this galaxy was, think of smoke rings, kind of. I mean, it wasn't that, but, or like trails from, when you see an airplane and they do skywriting,
Yes.
okay, those are trails of gas that make the writing, right? So
Okay.
this galaxy had a trail of gas coming from it,
Okay.
right? Now stop and think before we read again. Okay, if there's gas coming from it and it's out here, it's probably not hot, right? Could be cool gas, we don't know, right? But if it's hot gas, that would tend to believe that, first of all, we don't have a vacuum in the universe, right? But here's the thing, we see gas, but the thing is, from the picture, is it coming in or is it going out?
Okay.
We don't know that yet. Okay.
They figured out that it wasn't just a dark spot from the stuff that was coming down.
Right. Okay. But here's the thing. We don't know. Yeah. So we know it's causing the rain, but is it going in or out? Now here, he says, according to previous speculation, previously, before, okay, these strands were gases that were blown out. So they used to think that it went out, right? That it went out. But he said, Fabian, however, disagreed. He disagreed. It wasn't going out, it was coming in. So Fabian says this trail is not gas that's escaping, it's gas that's coming into
Okay.
the galaxy, right? And because they're visible in optical photographs, he suggested that such strands, not of gas blowing out, but cooling flows, bless you, streaming inward. Now, why did he think that? He noted that the wavelengths of the radiation, bless you, he noted that the wavelengths of the radiation became cooler. It would emit not X-rays, but visible light, and visible light was what was captured on the photographs.
Oh my God.
So this is actually cool gas that's flowing in to.
So it's going in the opposite direction.
From what they thought, exactly, right.
Okay. Now I get it.
Now, Fabian's hypothesis was supported by this other guy. He determined in 1982 that most of the gas in the Perseus cluster was at a temperature of 80 million degrees Kelvin. Kelvin is another temperature scale that we use in chemistry and physics. Okay, so this is 80 million degrees Kelvin, whereas the gas was 1/10 this temperature. So it was a lot cooler, right?
Okay.
So the gas in cluster, if this is Perseus, this is 80 million. This is 80 Kelvin right here.
So sorry.
It's okay. This is 80 million kelvins. 80 million Kelvin. Okay. But the gas that's flowing outside here, this is cool gas. This is cool gas. So this gas, remember, the
Oh my
thing
God.
flowing in here, the cool, what did we say? That it goes in the direction here, flows in, then it becomes cool in the center, right? And then this continues, this hot gas continues, becomes cool, and then excretes as rain. So that's, you see where this has gone?
Yes.
Does this make sense now?
Yes.
Okay, let me take a screenshot of this.
And I'm sorry I'm sneezing, but I just drank something.
No problem. Oh, not a big
Oh
deal.
my God.
I'm gonna clear the drawing now. And we're gonna go back to, let's see if I have, there it is. Now this is a different, let me go, actually, no. Let me go to the, that was the page that I got the passage from. But let me go to,
You should come over one day again.
yeah, I should. I need to make it over there
Maybe
sooner.
after my test.
Yeah, I hear you. Where's my, is this the one? Yeah, okay. This is the one. So let's look at
After
this.
my test, we can plan something.
Let's optimize that. And now let's watch this.
Okay.
Science passage, and we're going to read this together, and I'm going to try to prompt you to read this the right way. My objective here is to try to get you to form a habit. I always want you to read RC passages the same way.
Now, we just read a different passage than the one that he's gonna read right now. Okay,
Different one. Okay.
it's slightly different, okay? But he's gonna prompt us to read it properly,
Uh-huh.
okay? But I want you to get reading experience as much as anything.
Okay.
You know what I mean? We'll do the questions. That's not, I want you to get reading experience doing it. And if you need my help to understand it, that's fine, but it's only 7 minutes, so we only have to endure him for 7 minutes and 21 seconds. Okay, he's gonna read it, okay?
Okay, if you can form this habit, always approaching the passages the same way, you'll be able to see the underlying similarities across the different passages. Okay, and that's just like logical reasoning, just like logic games, the whole of the LSAT, the more you can see how everything's similar and related, the better you'll do. All right, so let's take a look here. Until recently, many astronomers believed that asteroids travel about the solar system unaccompanied by satellites. Okay, so just stop. There's no rush. Okay, in fact, if you...
Now, do you know what an asteroid is?
Yes.
Okay, do you know what a satellite means?
Yes.
So satellites would revolve around it, okay?
feel rushed to read on, you need to
Like
learn
Saturn,
to
right?
identify that, recognize that in yourself, and fight that urge. Okay, let's make sure we actually understand the first sentence. There are two really important things I want to make sure you got out of this. First is that this sentence should sound really familiar. Okay, and if it doesn't sound familiar now, it's okay. It's fine. At some point in the future, it will sound familiar. Because this is so common. The LSAT opens with, oh, some people, they believe this. Right here, we're talking about some astronomers, or many astronomers. They believe this. Lots and lots and lots of RC passages, LR passages open like this. Some economists believe this. Some psychologists conclude this. Right? So we typically call this other people's, position or argument? Well, at this point, it's just a position, but if you just read on to the next sentence, you realize it's actually an argument. So I'll table that. But that's the first thing I want you to recognize is just how similar it is. The author is opening not with a statement about what she believes, but rather with a statement about what many astronomers believe. Does our author agree with these astronomers? Well, we don't know. Likely not. Generally, that's just how it is. But anyway, okay, so that's the first thing I wanted you to recognize. Now, the second thing, of course, is actually focusing on the content. What are they talking about here? Asteroids. They're talking about asteroids in our solar system. And the question is, do they travel alone or are they accompanied by satellites? So hopefully this wasn't confusing for you. I know when we talk about satellites, typically we think of man-made satellites, right? Sputnik being perhaps the most famous. But there are natural satellites. Like, for example, the moon is a natural satellite of the Earth because the moon orbits the Earth. The Earth is a natural satellite of the sun because the Earth orbits the sun. Right? So here we're talking about an asteroid. And if something orbits the asteroid, well, that something is called a satellite. So that's the question. Do asteroids travel alone or are they accompanied by satellites? And some of these astronomers believe that they travel alone. They're not accompanied by satellites. So why do they consider asteroid satellite systems inherently unstable? They think it's just too unstable. Maybe for a little while, an asteroid will have a satellite traveling around it, but then they'll just sort of go off on their own way. See, here we're told the premise, other people's premise that support, like, why do they believe this first statement? Because of this. So you see, this whole thing makes up other people's argument, the first two sentences. Okay, so now we get some other perspective. Enter the theoreticians. And what are they saying? Well, they could have told them, referring to astronomers, these astronomers, otherwise, meaning what? Meaning that it's not necessarily inherently unstable. Okay, so both of these are referential phrases, so you should become sensitive to referential phrases and try to point them back to where they're pointing. So otherwise meaning, no, they don't have to be inherently unstable. Okay, how so? Well, even minuscule bodies in the solar system can theoretically have satellites as long as everything is in proper scale. So how minuscule? Well, even something as small as a bowling ball. If it were orbiting the sun in the asteroid belt, where most asteroids are, it could have a pebble orbiting it as far away as a few hundred radii or about 50 meters without losing the pebble to the sun's gravitational pull. So you see, we can have a...
Okay, so his point in all this is that passages typically start with other people's positions, okay? And that's exactly what happened in the passage, the long passage we read about the vacuum, right? Up until recently, people believed that space was a vacuum, right? But new evidence says that there's intergalactic rain, right? And so that intergalactic theory that used to be heretical was shown by Fabian to actually be correct. You see? So this pattern is similar, okay? And now he's going to go through
stable system with small things, according to the theoreticians anyway. Right, so here I'll just represent from lines 5 down to the end of the first paragraph. This is what the theoreticians believe. Okay, so lots of patterns here. Of course, all the use of referential phrasing, that's something you're never going to get away from. Okay, so make sure you pay attention to that. This style of opening with what some other people believe, contrasted with sometimes it's the author's opinion that counters what OPA is.
In
Here
our
it's
case,
even
it
more
was
other
two
people that counters
theorists that
the
were
initial
doing
set
it.
of other people.
Right.
So this style of contrast is something you want to get used to. Okay, and finally, at the end of the paragraph, you want to come up with a super low resolution summary. And I'll stress that. It's a low resolution summary. If I just tell you to summarize this, and I've just seen so many students do, what they'll do is they just start to read like every other word. Okay, that's not good. That's not a low resolution summary. You're going to end up with way too many details. It's going to be hard to remember, and it defeats the purpose. We're trying to get into the habit of reading for structure, and forcing yourself to do a low resolution summary is very helpful for that. So you can set some arbitrary constraints. You know, for example, just say, I'm going to try to do this in 7 words or fewer, or 5 words or fewer. Totally arbitrary constraints. Okay, so how would you do it? And actually try to do this. Pause the video, try to do this. I would say something like OPA versus theoreticians. That's it. Now, indeed, truly, this is low resolution. It doesn't even tell us what we're talking about. Are we like OPA versus theoreticians? So just two different people disagree on something, right? But you see, what's really nice about low resolution summaries.
So essentially for us, with our passage that we did before. It could be Orthodox view versus Fabian and Caransis, or whatever that other guy's name was, right? That's essentially what the low res here. I'd probably say asteroids accompanied by satellites versus the theoreticians, right?
Right.
So something similar to that, or versus the minuscule satellite. You know what I mean? He's just looking for the contrast at this point.
Okay.
Okay, that's all he's after. So let's go back to, okay, so we're looking at asteroid paragraph 1 analysis.
It's paragraph until paragraph 5, and then it gives you the question.
Do you want to go, you want to read the rest of it?
Yeah, we can read it. Let's read it together. That way you can explain, because this explanation just trips me.
Okay, so, but
Well,
that's where he's going,
I
right?
have
So
a pretty good idea of how he does it.
yeah, I mean, that makes sense. Let me,
Before moving on to the next paragraph, I
no,
want you to
we'll move
predict.
on. We're not gonna
You shouldn't expect yourself to be good.
blah, blah.
These astronomers, that's not right.
Okay, there.
But like I said,
You need to be quiet, sir. Okay, so until recently, many astronomers believed that asteroids travel about the solar system accompanied by, he explained this already. You okay with that?
Yes.
Okay. These astronomers assumed that because they considered asteroid satellite systems inherently unstable, okay, theoreticians, theoretical people, could have told them otherwise. Doesn't have to be that. Even minuscule, tiny, okay? Even minuscule bodies in the solar system can theoretically have satellites. So it doesn't matter how big it is, it matters the scale that it's on. And then they give you an example, okay? Observations now suggest, okay, so this is the read, kind of like our paragraph that we read. It talked about the vacuum, right? And how it couldn't have the vacuum because of this, right? Now it says observations now suggest that asteroid satellites may exist not only in theory. So the theory says they can exist, and you know what? In real life, they do. Several astronomers have noticed, it doesn't say who in this passage, while watching asteroids pass briefly in front of stars, that something is beside the known asteroid, blocks out the star as well. Okay, are you okay with this part?
Yes.
All right, let's go back and let's do part 3 now. Because I want to read the passage before we actually.
Yeah, we need to read it before we go to the question.
So again, I'm not gonna like. Okay, so we read to here, so I'm gonna pick it up with this. The most convincing such report, now what report? Remember, they thought they saw satellites, right? The most convincing such report concerns the asteroid Herculina. Remember, I told you a lot of bodies are named after Greek gods, and this is a feminine form of Hercules, Herculina, which was due to pass in front of a star in 1978. Astronomers waiting for the predicted event found not just one occultation. Okay, this is a fancy word for a darkening or a passing of, this is an eclipse, okay?
Okay.
An occultation. In other words, it hid part of it, right? because what happened is you had a star. Think of what happens to our sun, right? The moon passes in front of it, it hides the sun, right?
Yes.
So just like you have a star, something passes in front of it and the star dims because it's not because it got any dimmer, but because something passed in front of it. Was that something a satellite? Well, this Herculina report was the most convincing, right? There were not just one occultation, but two. One was the predicted occultation or the eclipse on time. The other, lasting about 5 seconds, preceded the predicted event by about 2 minutes. So we expected the eclipse, but there was like a miniature lessening before that, right? The presence of a secondary body near Herculina thus seemed strongly indicated. Okay, you see this? You follow
Yes.
here? Because we're seeing these dips in the brightness of Herculina, we think there must be something passing in front of it to sort of turn the lights out temporarily, right? To cause the secondary eclipse or occultation, an unseen satellite would have to be about 45 kilometers in diameter, a quarter the size of Herculina, and at a distance of 990 kilometers from the asteroid at the time. These values are within theoretical bounds, and such an asteroid satellite pair could be stable. So these are all the reasons why that body passing in front of Herculina could have been a satellite. Okay, that's what this is saying.
Mhm.
All right, let's go on to the
So
next.
moving on to the third paragraph.
No, I already did, sir.
I
We're gonna
understand.
move on.
I understood it better.
Better this time?
But you see how like my problem is not really reading, it's more like sometimes I trip over stuff that either I have seen, but I've seen it a long time ago.
Mm-hmm.
So like the way you're explaining it, it makes sense because I'm able to remember stuff. But like if I was doing it, like I'm not gonna remember astronomy class in 7th grade. Or
Oh,
like,
so now when you're reading it, you're remembering stuff
yeah,
you did
like
tie
you
it to?
explain to me, oh, this is what they're saying. I'm like, oh, okay, I remember this. Like it's not that I've never seen it. Obviously, you know, I had some type of explanation of it somewhere along the lines. But like if I'm reading it by myself, I'm not gonna pay attention to what the hell is saying because I didn't recall that instance.
Hmm.
That's why it's hard. Like even with the law passages, even if they're super dense, if they're talking about a certain law, I'm able to put two and two together.
Mm-hmm.
It's just science is hard.
Well, maybe what we should think about is doing, and I don't know, but he says the structure is fairly the same. So I wonder if maybe what we should think about doing is something like this, where you try to, okay, so there's an opening, kind of like opening remarks. I'm going to call it that. Okay. There's kind of like opening remarks. And in opening remarks, you're going to find out. So you're going to figure out the topic.
Okay.
Figure out like, what are they talking about? Are they talking about, like for us, they were talking about space being a vacuum versus the intergalactic rain. Okay. So for example, in our example 1, right? In the example that we read from Word, it would be something like space as a vacuum, right? Versus space having intergalactic rain. Okay, that's the first thing. Then you want to figure out the positions. The position slash the argument, okay? So what do you have going on here? You have, in this case, it wasn't two people arguing. It was the orthodox view that
And then you,
space is a vacuum, right? Space is a vacuum versus the heretical view by Fabian, right? Fabian the heretic, how dare he, that said that not only is there intergalactic gas, okay, intergalactic gas cools as it moves toward the center of the galaxy, and the cooling flows of hot gas that become cold cause the rain. Okay, and then it talks about some sort of evidence to the contrary, right? Well, he saw that because of the satellite, but maybe that's how we should kind of structure it. What is the topics? What is the positions and the argument? In this case, it's, do asteroids have satellites? Yeah, there's a report, right? So in this case, it's the orthodox versus the heretical. In your other example, the one we're reading right now, it's more about, okay, what are the topics in there? Well, the topics in here are talking about asteroids that have satellites, right? Versus asteroids without satellites, right? That's essentially what it is. So then you say, okay, what is our structure? So you have your opening remark. What is your structure? Well, the prevailing view, right, is that some asteroids were too small for that, right? But then the other people, the heretical people said, no, asteroids don't have to be too small. It's not about size per se. It has more to do with scale. Not just the size, but how big something is. Scale means how big something is in relation to something else. So this is one scale, right? And then this scale would be different. This scale would be smaller, right? This scale would be larger. So there is a point at which the scale becomes untenable, and this probably couldn't happen, but maybe this could happen. You know what I mean? But that's kind of the difference there. But maybe that's how you can approach it. Have you tried that?
no, I haven't.
And just think, think about the topics and think about
I've
like,
been doing it, like the structure that he said, where like two people arguing and then like what's the stance and things like that. But it's hard for me because, like I tell you, with the science one, like sometimes I don't even know what they're talking about. So when it comes to me being able to tell him, okay, you have to write this, and they're arguing on this, like I know that there's two stands, but that's as far as it goes.
mhm.
I'm not able to dissect like the rest.
Well, maybe what we should practice on, and we'll finish the passage, but what if as a bridge to that, you were to, if you were to, oops. If you were to read a passage and set it up this way, like, don't worry about answering any question.
Okay.
Just think about, okay. And there might be more than two topics, but let's do, what are the two topics?
Yeah.
Okay, what are they? 1, 2, right? There they are. 1, 2, there they are. What are the two topics? Then, okay, and sometimes and then here they give you what is the,
Argument.
well, before we get there, what are the positions? I mean, let's break this down so I can see where your problem is, okay? What
Okay.
are the positions?
Let me go leave this to the kitchen so I can have more space
Yeah, no worries.
while you write that, and then I'll be back.
And then trace the argument after that. So who or what group argues which position?
Okay.
Okay, so what I'm gonna do,
Uh-huh.
I have Myrna in 10 minutes, so I'm gonna see if she's gonna come.
Okay.
Let's see where she's at. I'm going to send you this little template. I'm gonna shut off the recording.
I have time tomorrow too.
I'm gonna shut off the recording.